Thanks for the presentation, Jalmari. So really, my name is Lauri Lemmenlehti. I'm the CEO of Plehat. Um, we're a 2.5-year-old startup now residing in Aalto University in residing at the campus of Aalto University in Espoo. And I'm just gonna our kind of like our company, which is a combo of game engine developers and landscape architects, is a little bit weird. So I'll frame this a little bit with a small video. So this is a small video about the kind of like the history of how the landscape has developed in video games in the past 30 years. And it starts in the mid 80s, and then it kind of like it really starts to bloom around 2010. And one thing is, of course, kind of like the accelerated 3D graphic cards come. But at the same time, the whole industry has developed into a mega billion industry, which has so much more of developer assets, art assets, all sorts of other stuff you can use to actually do this kind of like realistic environments. Yeah, so our company started back in 2010. The idea, at least, uh, when I was still studying landscape architecture, and there's a Finnish video game studio called Remedy Entertainment, that did Max Payne and more recently Quantum Break, and Control is coming out. It's quite close to Aalto University also now. But in 2010, they released this very long development process with Alan Wake. And Alan Wake is this video game that's situated in northwest United States, and it's this kind of like Stephen King kind of story-based action thriller horror game. And I remember, because I'm a video game enthusiast myself, and I always was trying to kind of like play all through the Finnish games. And I remember looking at the game and had studied a few years in landscape architecture, and I was really looking at the natural environment, and it was way ahead of everything that we had seen before. And I was like, man, like I haven't seen this. Like the designers really must know what they're doing. And I started to look it up a little bit, and turned out I was right. I was totally right. So the level designer who had created the natural environment where the most of the game works, had studied landscape architecture in the same department I had, and I contacted him, and we talked a little bit about the whole process. But basically, what had happened is everything that he had studied over landscape analysis, he just roughly reverse engineered it into the game, and it works. And even from like today's standards, even though the graphics has gone quite a lot of ahead. Okay. Here's like from last year, Red Dead Redemption 2, which has an absolutely wonderful natural environment setting. Um, so, but it still holds on after 8 years of development, and everybody who follows video games knows that 8 years is a lifetime in game development. But the funnier thing is Rockstar Studios, that also does Grand Theft Auto series, which is maybe like the open world game, like pulp fiction of video gaming world. Um, the architect who designed the natural environment of 100 square kilometers in Grand Theft Auto 5, for those who played, the guy, who's a Scottish guy, he actually lives here in Helsinki for by happens, and I found out that he lives in Helsinki, and I contacted him and interviewed him for my master's thesis about the kind of like development of Grand Theft Auto 5, of the natural environment. And I was asking, like, hey, how many people were there working in the project? And he said, like, well, we were like 2.5, 3 years, 20 to 30 people groups. As a landscape architect, there's absolutely no designing projects of 20 to 30 designers working for 2.5 or 3 years in a design. So we moved from a kind of like from a situation that actually the natural environment planning are like the biggest natural environment planning processes are not anymore physical, but they're actually digital. So basically going, I'm sorry, I'll just have to read a little bit. What did I? So we really started to question after my school. I started a company with my friend, and we really started to ask the question, like, could we do something similar with game engines? And in landscape architecture, we haven't used software. It's not really taught at school. Nobody knows them. We look at architecture models, but it's not really used. There's no really tools for it. And and there's a big difference between planning for architecture and landscape architecture, even though there's the word architecture. So basically, when you're building a model of a building, it's mostly static, it's geometrical, it's not very difficult. But if you have to build nature, you have to build plant life, you have to show all the processes. Landscape architecture is not building about objects of park. It's about designing processes, intertwining long period processes. The thing is that if I design a park and it's going to be built, it's not going to look anything like that what I kind of like had in my head when I was planning it. It's going to take, it's going to be built, and then you put the timer on and wait 30 or 40 years, and then it slowly starts to be kind of like what I was thinking. So, if we can accelerate this process, we can visualize, then we could actually like see the whole and actually integrate these processes into the landscape architecture design process itself. But then, of course, the question is that if you want to, like, well, if you build a house, you're going to need the wall, you're not going to need the doors, you're going to need the windows, you're going to need the roofs. But like, if you do natural environment, what are you going to model? What are you going to actually do? And in landscape architecture, there's a few different schools of how do you do analysis. And in our school, this is what was taught. So if you try to kind of like do big scale planning, you're going to you're going to make an analysis by layers, and you're going to think about the bedrock, the soil, land cover, water, climate, animal, and structures. But the thing is, like, this is a tool, it's not very clear. And then we actually tried to exactly like, if you're gonna try to model the environment, you're gonna try to reverse engineer this. So if you want to build a landscape from scratch, actually this is not like something that we never get. So as a landscape architect, you're always it's always an intervention, your design. Like even if there's just like something has exploded, there's still the bedrock, there's still the climate that you have to deal with. But we never, it's always an intervention, and we always have to kind of like work with the living nature and what does exist already. And in that way, if you start to do a digital model, you have to do quite a lot of decision making. What are you going to bring into the model? Um, so, and then if you have to start from scratch, then the question is, are you going to bring what is more important? Is it the kind of like actual elements, or is it the processes? So what do you actually model? And since this listing was made mostly for the analysis, it it doesn't work. So if you want to combine of these, that you will get ahead, that you have to do the actual natural environment elements, say let's say trees and shrubs and ground and animals, um, plus the processes, you have to include the temporal variancy of these different layers. And as we know, if we look at the bedrock, it has a slightly slower change rate than, let's say, butterflies. And if you want to make the natural environment model practical, you have to consider this, that you have to make decisions over what are you going to model, how are you going to model. And our bet is that it's very heavily, you have to invest quite heavily into these different groups of elements that synchronize to each other temporally. So with landscape architect, we use BIM. We also have LIM, so landscape information model. But since what has happened is, like I said, these BIM models are static objects, and we need to show the long time processes of growing, evolving, living things. So we're in trouble with BIM. No matter where you go, you're going to be in trouble if you want to really model the natural environment. And now coming back to the video game video, the thing is like I could believe the world of Alan Wake or Grand Theft Auto or Red Dead Redemption. Like, why don't we have that in city planning? Why don't we use those kind of tools in landscape architecture? And well, the question was that, like, why won't we? So why wouldn't we? So we started to really study different game engines. So we're working both on Unity 3D and Unreal Engine, where it seems that we are going towards Unity, even though Unreal Engine gives better graphical quality in general. But for us, at least, Unity seems more clear, as a more clear path into the future. Just as a small notice, because we're a small office. We're 10 people, and we're really a startup. So we just try to survive. So these kind of things, that are you gonna do Unreal? Are you gonna do Unity? They're like big actual questions. And the funny thing, how like we were looking at different options, and a few years ago, CryEngine from Crytek, which was always technically the best, and that had the best natural environment elements ready, and it was going bust. They had CryEngine game engine, and Amazon came and licensed their engine, and they built on top of CryEngine. They built up Lumberyard, and they gave it for free to use for anybody, and poured billions of dollars into the whole thing. And they couldn't breach this duopoly that we're seeing here. So my bet, just as a kind of like general view on the whole game engine industry, which is, for me at least, the next natural step from all sorts of BIM softwares, is that the whole industry is set now this is the same situation that we had in 2008 when there was iOS and Android, and eventually there wasn't space for any other softwares anymore. There are scientific tries like Godot game engine from MIT. There are different tries, but these two have grown into such big technical ecosystems that it's really hard to break through these. So I would bet my money that the kind of like the future of any XR development is one of these two. Lately, Epic, who builds Unreal Engine, actually bought out Twinmotion, which is this French company that does Twinmotion Engine, which is combination between BIM and game engine graphics. And that's a huge sign that even Epic is looking at the field of architecture really seriously. So we have a few products. So we've had a lot of great discussion here about kind of like about the theory. Where should we go? What shouldn't we forget in the whole process? And what's nice about in a startup is you're broke all the time. So you're really kind of like you really have to try to make things work. And then like we wanted all these ideas about showing the dynamic environment, you know, like that you could show not Finland in the summer, everything looks great, whatever you do or you design. The holy grail for landscape architects, like, can you make it looking nice in the mid of November at 7 o'clock in the evening? So and we could actually show that, and we could build easily a system that works really nicely. And you know, it's a game engine. You got already artificial intelligences in video games. We've had them for what, 15 years. Why don't we use those for scientific measures? So we added some you know, butterflies. We added some birds, whatever, and we really kind of like try to kind of like, if you want to build this framework of a landscape time machine where you can control the time, where you can control the climate, where you can have all these dynamic and intelligent agents, what would it look like? And I just have a small video of our space-time program. So we call our software the space time. So we have a lot of different modes. So we have VR mode. We built it originally on VR. So VR is difficult to do. So once you do that, it's actually quite easy to do an FPS. You can control the sun. So you see the shadows moving here. We also, what you see in Mikko's hand there is we build, instead of kind of like you choosing from the screen, what do you do? We integrated a game control into it. Uh-huh. There seems to be some segment. Yeah, it's okay. So we also wanted, like, you can comment into the model whatever needs to be commented. So we don't know exactly where is this going to go, but we're going to think that it's going to be a big issue of kind of like using these new ways of commenting and communicating these environments. It's really important to be able to comment on the spot, comment on the time, use a timestamp, and be able to derive that information out of the model. You can, of course, move freely within the models, and this model is from Uunisaari, which is in front of Helsinki, in front of Kaivopuisto in the south. For us planners, we want to use this for the wider public, but as a design tool, it's extremely useful. And the more, because we actually use this in part of our kind of like everyday designing work, uh, we've learned quite a lot, like what part the FPS works, for what part uh, does a VR thing work. But you have to be quite good. So of course in game engine it's easy to do, but we also we built like our own algorithmic plant libraries, so you can actually just plant on the site depending on what you want, and then they become automatically part of the dynamic environment. And then as architects, it's always important important to be doing these different shadow analysis, which are usually still done in 2D. So here you can see the controls, and we have, you can just kind of like control. Basically what happens is kind of like you control the height of the sun, the position of the sun, and depending on where is it on east west, depends, is it morning, evening, or day or night, and then up and down, you kind of like control the months like it goes in real life. Yeah. And yeah, so let's see, there's the space-time video. So I'm going to be here showing at 1 o'clock with Santeri Suominen here at the XR Center. I'm going to kind of like be showing the demo. But if I just quickly, we have 0 minutes left or 30 seconds left. But if I'm just going to quickly talk about the future, like of these models, and like continuing a little bit to Stefan's talk. So basically, when you build these let's say artificial insect models, you can do that. We have the technology for that. We have the framework for that. Or let's say you're going to build algorithmic plant life that's based on L system, like they how actually work. So fractals, algorithms. The thing is, like, if you plant something now, we can make a decent approximation what the tree is going to be growing if it's in an optimal situation. But the great thing is that we can do this approximation and guesses what the future is going to be for the natural environment, and then we can look what's going to happen. We can just wait for 5 years and see if it's going to fit. And most likely, we don't know as much as of natural environment that we'd like to admit. So we know that there's the mycorrhiza, the mushrooms underground, are extremely important for the plant life. We know that there are effects of the landscape bacteria, but we really don't know like that much about it. And if we start kind of like moving these visual and building information models into the natural life in these urban environments, we can start kind of like pulling big data out of this. So we can make predictions, see do they work, if they don't work, if they didn't come out as we thought, we can make another prediction and kind of like and start getting a better resolution of where we are going. And what I'm suspecting is that once we start taking steps into these simulations of the natural environment, there's going to be a lot of these unknown factors that we didn't even think about. Well, that's basically it. We try to make this. We try to work between technology and landscape architecture at Blehat. We are not absolutely sure where we're going with this, but we really think that this is a huge opportunity for cities in urban areas in the whole world. And I hope we can start, maybe even from Helsinki here, we can start building a digital twin, not only of the buildings, but of the whole natural environment, and do and answer a lot of these questions that we have on how to preserve the environment when there's more and more people in more and more cities all the time. Thank you very much.